Today we're going to shift things to adding and subtracting radical expressions. Just a general rule, you may only add or subtract like roots. Just like adding like terms, you keep the root the same and you add or subtract the coefficient or coefficients out in front of the roots. So let's begin. We're going to simplify these expressions. I notice I have like roots of root 3. So I'm going to add or subtract the coefficients out in front. I have a 9 and a 4 as coefficients. Subtract those, that's 5, and I keep the root the same, that's 3. Similarly, in this second example, there doesn't seem to be a coefficient out in front. However, there's an invisible 1. It can't be a 0 because 0 times anything would be 0. Therefore, I have 1 minus 7, which is negative 6, and I keep the root the same of n. So in this case, you'll notice I have 3 terms, 2 of which have like roots, 1 of which doesn't. The only things I can add together are the coefficients out in front of the like roots. So that's 2 plus the 9, which is 11, and I keep the root the same of xy. And then I'm just going to add to that 2 root y. And I leave this as my simplified solution. In these next examples, you'll know that neither term has like roots. However, each of the terms in these two expressions are not simplified. So I need to go ahead and simplify these radicals first to see if any like terms exist. So I go ahead and I say, well, what perfect square is in 45? That's 9 and 5. In 20, I have 4 and 5. So this goes to the square root of 9 times the square root of 5 minus the square root of 4 times the square root of 5. This is 3 root 5 minus 2 root 5. I have like roots now. I subtract the coefficients out in front. So that's 1 root 5, which you can just say is root 5. Over in this next example, I have 9 times root 25 times 3 plus 2 root 25 times 2. This goes to 9 times root 25 times root 3 plus 2 times root 25 times root 2. In this case, I have 9 times 5 times root 3 plus 2 times 5 times root 2. This is 45 root 3 plus 10 root 2. Notice there are no like terms or like roots present because I have root 3 and root 2. Therefore, this term is completely simplified. In this next example, we have a similar situation. None of the radical terms seem to be alike, but also there are perfect square factors in each of them. So let's go ahead and simplify those. 75 is 25 times 3. We have the y also. 27 is 9 times 3. And 48 is 16 times 3. So we go ahead and break these apart. Root 25, root 3y, minus 2 root 9 root 3y, plus root 16 root 3y. This is 5 root 3y, minus 2 times 3 root 3y, plus 4 root 3y, or 5 root 3y, minus 6 root 3y, plus 4 root 3y. All the root terms are alike, therefore I can add all the coefficients out in front. We have 9 minus 6, which is 3 roots of 3y, and that's my simplified term. So now we're going to simplify this expression. They're asking that we go ahead and multiply 2 root 3 by this quantity here. And the rules, once again, we multiply the coefficients by the coefficients and the roots by the roots. So this goes to 10 root 15 plus 6 root 18. I need to see if any of this simplifies. Root 15 will not. 18 breaks down into 9 and 2. So this is 10 root 15 plus 6 root 9 root 2. 10 root 15 plus 6 times 3 root 2, which goes to 10 root 15 plus 18 root 2. There are no like roots, therefore I can't add these terms together. So that's my simplified form. So we now have a binomial squared, and the best way to handle that is rewrite the binomial twice and FOIL together. So I have 25 minus 20 root 3 minus 20 root 3 plus 16. Root 3 times root 3 is root 9. So you'll see in this case that I have 25. Oops. And I can add the like roots. Minus 40 root 3 plus 16 times 3 in this case, because the square root of 9 is 3. This goes to 25 minus 40 root 3 plus 48. 25 and the 48 are like terms. That's 73 minus 40 root 3. Again, we have two binomial terms that have radicals in them. I'm going to have to FOIL this. 2 times 3 is 6. Root 5 times root 2 is root 10. Multiply 2 times the coefficient out in front of this term is 1, so that's 2. Root 5 times root 10 is root 50. 3 times 3 is 9. Root 2. 3 times 1 is 3. Root 10. So let's simplify everything that I can. I notice right off the bat that this root 10 and root 10 are like roots, so I'm going to make that 9 root 10. I'll simplify the 50 into 25 and 2. The 9 root 2 stays. So I have 9 root 10 plus 2 root 25 and root 2 plus 9 root 2 is 9 root 10 plus 2 times 5 root 2 plus 9 root 2. This is 9 root 10 plus 10 root 2 plus 9 root 2. And now have like roots here. I can add the coefficients out in front, so this is 9 root 10 plus 19 root 2. And no more simplification can be done. That's all we've got. Go ahead and simplify these expressions and write your lesson summary, and we'll discuss this more tomorrow.